Section 1.9, distance and midpoint formulas and circles. So our objective for this section is to find the distance between 2 points, find the midpoint of a line segment, write the standard form of a circle's equation, give the center and radius of a circle whose equation is in standard form, and convert the general form of a circle's equation to standard form. So this section is a little bit of geometry, but all of these ideas, distance, midpoint, and circles, are going to come in really handy when we start talking about things like unit circles and dealing with the triangles inside there. It's also a good idea to know your way around the circle, right? Lots of angles, maps, compasses, they're all based on circles. They occur everywhere in nature. And our rectangular coordinate system, our Cartesian plane, gives us a unique way to know how a circle works. So let's start by getting into a little bit about how to find the distance between 2 points as an algebraic equation. Okay, so the distance formula comes from the Pythagorean theorem. And the Pythagorean theorem simply says that a squared plus b squared is equal to c squared. Okay, I'm just going to write that backwards. I'm going to just say c squared is equal to a squared plus b squared. Because as I look at this picture on the right, we can see that to find this distance between 2 points, right, that's going to be kind of like the hypotenuse of a right triangle, which the Pythagorean theorem tells us how to find. Because if this is side C, we can call the other two sides A and B, and now I have a Pythagorean theorem. So the distance between these 2 points, which is, since it's on a straight line like that, since it's on an axis, if I want to find the distance between point x2 and point x1, all I have to do is subtract them. Okay, same thing with y2 and y1. Okay, so now looking at the Pythagorean theorem here, I can use these ideas to give myself a equation that I could work with to find the distance, which is that term right there. So I know there's going to be a right angle because I'm going to go left and right and then up and down. So that's the definition of a right angle. Okay, so because the dashed lines are horizontal and vertical, a right triangle is formed. So we can use the Pythagorean theorem to find the distance d. Squaring the lengths of the triangle sides results in positive numbers, so no absolute value notation is needed, right? No matter where I start, it does not matter if this distance is positive or negative. Okay, so I have x2 minus x1 squared, or a squared, y2 minus y1 squared, or b squared, and then the d on there would be my c squared. So I have the Pythagorean theorem right there. Then I'm going to take the square root of both sides using the square root property. And I get this plus or minus right there. But I can get rid of it because distance is non-negative. All I need is the principal square root. And the equation that's left over there after I do all this is called the distance formula, which we can see right here again. So the formal definition for the distance formula is the distance d between the points x1, y1 and x2, y2 in the rectangular coordinate system is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. To compute the distance between 2 points, find the square of the difference between the x coordinates plus the square of the difference between the y coordinates. And the principal square root of this sum is my distance. Okay. When we use this formula, it does not matter which point I call x1, y1, and which point I call x2, y2. But we should get used to going in order. So -1 comes before 3. So I'm going to call this one x1, this one x2. But it doesn't matter either way. So to find the distance between these 2 points, my distance is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's just my distance formula. Now I just have to fill in the numbers. So x2, which would be 3, minus -1 squared plus -2 minus 4 squared. And -3 minus a -1 minus a minus turns into a plus. So I now have this, the square root of 4 squared plus -6 squared, which gives me 16 plus -6 times -6 is going to be 36. And this is not equal to 4 plus 6, okay? That's no good. That would be the square root of 16 plus the square root of 36, okay? That's not what the distance formula does. They're both underneath the square root, so we have to add them together first to give me the square root of 52. And now, express the answer in simplified radical form, and then round to 2 decimal points. So 2 different ways to calculate my answer here. The first is to split it into a radical form. So that's radical 4 times radical 13, which would be 2 radical 13. And then if I pop this into a calculator, I would get that it is about 7.21. Okay. So using the distance formula is the hardest part there is to put all the numbers in the right spot and to be sure that we are calculating the correct form of my answer. And in this case, we did not have any units, so this is a unit measure, just 2 random points. But if we did have units, distance would be in terms of units. Okay, so next is the midpoint. So the midpoint formula comes from the distance formula. It can be used to derive the formula for finding the midpoint of a line segment between 2 given points. Okay. The simple version is that if we want to find the middle of something, we can just take the average of the 2 points. We can just add them together and divide by 2. So consider a line segment whose endpoints are x1, y1 and x2, y2. The coordinates of the segment's midpoint are x1 plus x1 plus x2 over 2, comma, y1 plus y2 over 2. Okay, so we're going to take the average of the 2 x coordinates and the average of the 2 y coordinates, and my answer is going to be a point. Right? We're going to have 2 coordinates. We're going to have the x coordinate and the y coordinate with a comma in between, in parentheses, to designate a point. Not a number, like the distance formula just gives me a number. The midpoint is going to give me a point. Now, a good question that people ask is, do I add or subtract coordinates when applying the midpoint and distance formulas? So just be careful with the formulas. The midpoint formula requires finding the sum of the coordinates. By contrast, the distance formula requires finding the difference of the coordinates. So this is going to be a sum. This one is going to be a difference. Easy to confuse the two. Very, very common mistake when trying to calculate these two numbers. Okay. So just be careful. So let's find the midpoint of the line segment with endpoints 1, -6 and -8, 4. So my midpoint, let's break it down. My x coordinate of my midpoint is going to be x1 plus x2 over 2. The y coordinate of my midpoint is going to be y1 plus y2 over 2. So for the first one, we get 1 plus -8 over 2, which would be -7 over 2. And the next one would be -6 plus a -4 over 2, which gives me -10 over 2, which is -5. Don't leave my answer like that. My answer is a point. So it's -7 over 5, comma, whoops, negative 7 over 2, comma, negative 5. Okay. Okay to get fractions. That's fine. Okay to get negative numbers. These are points. It's not a distance that has to be positive. This is a point. It is normal to get a negative point on some sort of Cartesian plane. All right. So that's distance and midpoint. Let's now jump in to the equations of circles. Okay, so our goal first is to translate a circle's geometric definition into an equation. So the geometric definition of a circle is the set of all points on a plane that are equidistant from a fixed point called the center. The fixed distance from the circle center to any point on the circle is called the radius. So with this in mind, you can draw a little figure and figure out how to get the equation of the circle. So figure 1.76 is our starting point for obtaining a circle's equation. We've placed the circle into a rectangular coordinate system, xy plane. The circle center is right there, h, comma, k. And xy represents any point on that whole circle. And by definition, the distance between the two of them is the radius. Okay? So with that in mind, right, with this little dashed line being the radius, I have a formula that calculates distance. So the geometric definition of a circle tells us that xy has to be r away from hk. So that means that if I take those 2 points, h comma k, x comma y, x as x1, h as x2, I can say that x minus h squared plus y minus k squared is always going to be equal to r. Take the square root, and now I have my distance formula. So the distance between xy and hk is r. And that's the definition of a circle. If I square both sides of this, like that, I get an equation for the standard form of a circle. X minus h squared plus y minus k squared is equal to r squared. And this is my equation that I will use to graph and label circles. Okay, so write the standard form of an equation with a circle with a center 0, 0 and a radius of 2. So let's just slide this over for a second. My equation for a circle is x minus h squared plus y minus k squared is equal to r squared. Now we can just fill in the numbers. There's h and k, so it would be x minus 0 squared plus y minus 0 squared is equal to 2 squared. X minus 0 squared is just x squared plus y squared is equal to 4. And that's my equation for this particular circle with a center of 0, 0 and a radius of 2. To graph this, I'm going to start with the center. The center is at the origin here. Now, I know that every point has to be 2, which is the radius, away from the center. I know that's 2. I know that's 2. And that one, and that one. But I'm really not sure where 2 is if it's not on one of the axes, on the x-axis or on the y-axis. So those are going to be the 4 points that I'm going to use to draw my circle. And all we have to do now is just put a nice smooth curve through this, and we get a good circle. Okay. Yes, I cheated a little bit with some of my drawing tools, but we get the idea. Just do your best. It didn't look like my first one was going to come out very well, but thankfully I have a nice circle making tool. Let's try it again. The center of my previous circle right here was on 0, 0, was on the origin. Okay, there's my center. Let's try one that's not on the origin. So now, write the standard form of the equation of a circle with the center of negative 2, 3 and a radius of 4. So when I write my equation for this circle, remember that my equation says x minus h squared plus y minus k squared is equal to r squared. So this is going to go and turn into x minus negative 2, which turns into a plus. Plus y minus 3 is equal to 16, 4 squared. Oops, squared. Okay, so notice here that the signs of my 2 points that are the center do change in this formula because the formula has minuses in them and not a plus. So again, start with the center, which is negative 2, 3, and then use the radius to graph the circle. So when I graph this circle, I'm going to start by going 4, 1, 2, 3, 4, 4 to the left, 4 down, 1, 2, 3, 4, 1, 2, 3, 4, 4, sorry, 4 right, and then 4 down, 4 up. And again, we try to draw as well as we can a nice, smooth circle. All right. So let's use the same technique again now to find the center and the radius of a circle whose equation is now given to me. Okay. So the center is going to be these 2 points, h comma k, and remember I changed the sign. So when I do this, my center becomes 2, negative 4. My radius is going to be that number right there is the r squared. So my radius is going to be 3. So if I wanted to start to graph this, I would start at the center, 2, negative 4, and I would go up 3, right 3, down 3, left 3, and use my shape tool to make a nice circle. Oh, that one wasn't so good. Slide it over a little bit. And there we go. Let's use the graph now to identify the relations domain and range. Remember, this is not a function, fails the vertical line test, but they are still things that we can graph, obviously, and write equations for, like we've been doing. So now if I look at the domain of this function is going to be the x values for which it's defined. And I can see that this function is defined between those 2 x values. And it does touch those 2 x values on the very edge there at the 1 point directly right and directly left of the center. So I can say that the domain of this function is from negative 1 to 5, including negative 1 and 5. The range of this function, if I look on the y-axis, the function starts down there, or sorry, not the function, the relation starts down there and goes up to there. So it goes from always smallest to biggest, negative 7 to negative 1, including negative 7 and including 1. All right. So what's the bottom line when identifying h and k in a standard form of a circle's equation? So it's easy to make sign errors when finding h and k. The center, keep in mind that h and k are the numbers that follow the subtraction signs. So if it's x minus 2 squared, h would be 2. If it's x plus 4 squared, that means you had a minus minus 4, which means the center is at negative 4. Okay? So just be careful with that. Let's take this equation right here from this problem and let's change it around a little bit. So if we square these 2 terms, x minus 2 squared and y plus 4 squared, if I FOIL them out, I get x squared plus 4x plus 4, y squared plus 8x plus 16. Okay, then I can clearly see that these two can go together to give me 20. And if I subtract 9 from both sides, I now have set this equation equal to 0. This is a different form of an equation for a circle called general form. So general form of a circle's equation is x squared plus y squared plus dx plus ey plus f, where d, e, and f are all real numbers. Okay, and notice that there are no leading coefficients in front of x squared and y squared. And that's important because when we try to figure out the equation for the circle, we're going to use techniques similar to what we did when we were factoring and what we were doing when we completed the square. So it's important to have both of those numbers be a 1. If they're not a 1, we could always try to make them a 1. That would make a little bit more challenging problem. We can make them a 1 by dividing out the numbers across all the equation. Okay, so we can convert general form of a circle's equation to standard form. We do so by completing the square on x and y. So let's see how it's done. So here's the standard form of an equation. Hard to graph that way because numbers like the center and the radius are not obvious when we just look at the equation. So what we want to do is we want to complete the square. And the way I'm going to do that is I'm going to write the x's together. X squared plus 4x. Then I'm going to write the y's together, plus y squared minus 6y. And then I'm going to move the 23 to the other side. Okay, so basically I just used the commutative property and I moved these two around. And I subtracted 23 from both sides to get my new equation. Okay, and I left some spaces in the middle there. Okay, because what I'm going to do is I'm going to take x squared plus 4x plus something, and then y squared minus 6y plus something, and set it equal to 23. And what those two somethings are going to be is going to be the thing that makes this a perfect square. And the way I can tell that is take the middle term, divide it by 2, and square it. So 4 divided by 2 is 2. Squared is 4. Negative 6 divided by 2 is negative 3. Squared is 9. And see, it doesn't matter if it's positive or negative. I'm going to always wind up with a positive when I square it. Now I'm adding 4 to the left side and 9 to the left side, which means in order to keep this equation balanced, I have to add them both to the right-hand side as well. Now, this trinomial in the beginning is a perfect square. It happens to be x plus 2 squared plus, and the second trinomial is also a perfect square. That was the point of completing the square, to make it a perfect square, so that way I can factor it. Y minus 3 squared. And that's equal to 23 plus 4 plus 9 is 36. And look how nicely that worked out for us, okay? Because now I can graph this fairly simply because now I know the center. The center is going to be negative 2, 3, right? Opposite sign, opposite sign. The radius is going to be 6. So we start at negative 2, 3. I'm going to go 6 up. 1, 2, 3, 4, 5, 6, right to the top. 1, 2, 3, 4, 5, 6, right. 6 down, and 1, 2, 3, 4, 5, 6 left. Okay, gonna get a big circle. So nice, careful drawing here as we whip it around. Oof, not gonna work. But again, I have a nice little tool. Didn't even work out that nicely. I got a little, let's make this a little bigger, even a little bit bigger. Close enough. Okay, so definitely do your best. Drawing a circle is very hard to do freehand. I am clearly not good at it, which is why I use the software to help me do it. Okay, so I believe that is everything. Yes. So that was 1.9 distance and midpoint formulas and circles.